So here once again is our graph of the volume of a box versus the length of the cut that we put in it to be able to fold the sides up. And clearly the one that we have here is the restricted domain version, the one that Athena wanted because of the real life situation that she was using this in conjunction with. However, let's take a second to look at the equation for this function. We had a of x is equal to 7 minus 2x times 5 minus 2x times x. And you'll remember earlier on I multiplied all of this out. And when we do all of this multiplication out, we get a different form for expressing this function. 4x cubed minus 24x squared plus 35x. Now the reason that I wanted to do the multiplication out right now is that I think you might notice this equation is pretty different from anything else that we've graphed so far in the course. In particular, we have an exponent of 3 in our function. What on earth does a graph that has a third degree term in it look like? Well, why don't we get rid of these domain restrictions briefly and zoom out and look at the entire graph that this is part of. So here's the full version of our function without any domain restrictions. Multiplied out, the function itself is 4x cubed minus 24x squared plus 35x. This is a totally different equation than anything we've dealt with before, graphically at least, though we did see expressions that look like this early on in the course. Because this function has a different degree than other functions we've dealt with, it's going to have different graphical properties as well. Now I've labeled a few different special points on the graph, or points that may potentially be special, and I'd like you to help identify what they are. So in each of the purple boxes over here, to complete the statements, I'd like you to fill in letters that go with these different points. And that's this blue one right here. This I'd like to be a number that you just type in. So basically I'm asking you which points are the x-intercepts and how many are there, where the function changes from increasing to decreasing, and when it changes from decreasing to increasing.